Hello everyone. Today we're going to continue lesson 16.1 on day 2, the properties of logarithm. And we're going to continue using the properties of logarithm to simplify expressions and rewrite logarithm models. And let's take a look at more practice problems. So this is pretty similar to the problems that we did yesterday, except maybe just a little bit longer. So let's go ahead and take a look at the first one. We already see a power rule that needs to be applied. So there's a 5 over here, and we're going to start by solving the problem without moving the 5 first. So we're going to rewrite the 16 as 2 to the 4th. And then don't forget we have a 5 outside. And we have log 2 of, let's multiply 4 times 5, which is 20. And therefore you have these two will cancel out. And the answer is 20. Next, we have log base 4 of 16. So we're going to rewrite the 16 as 4 squared. And don't forget you have the x minus 1 in the exponent. And we're going to cancel out the log base 4 of 4. And we have 2 times x minus 1, which now we can distribute. And we get 2x minus 2 as the final answer. It's pretty easy so far, right? So once you feel a little confident in working with the logarithm, it's actually pretty fun. And next problem, we are going to solve the one that has a negative exponent. So log base of 6, so 1 over 6 to the 4 is actually 6 to the negative 4, believe it or not. And we have 3. So we have log base 6 of 6 to the negative 12. Log 6 of 6 cancel out. And then we got negative 12 by itself. And that will be the answer. Here is a little friendly reminder regarding the sound, measuring the loudness of sound in real-world situations. And this is the formula that is being used for I is the sound's intensity and an I naught is the barely audible sound. And also that it is also possible to develop logarithm models from exponential growth or decay models in this form and this form. So we have f of t equals a 1 plus the r. So these are used to find the ratio problems like interest rates, growth and decay with money. So let's take a look at a problem that actually has to do with value increasing or decreasing. Example 1. Carmen has a painting presently valued at $5,000, and an art dealer told her the painting would appreciate at a rate of 6% per year. In how many years will the painting be worth $8,000? So part A says write a logarithm expression representing the situation. So we are using the formula for the growth here that we are told because we actually have a growth situation. So we got we're going to let P be the value of the painting, and it's equal to A, the initial value, we're going to call it P naught, times 1 plus R to the T. And so we're going to substitute the values that we know. We know the initial value is $5,000, and then the interest rate is growing 0.06 per year to the t power. Simplifying that will be P equals 5,000 times 1.06 to the t. And that is going to be the formula that we use to represent the growth. And part B says, simplify your expression. In how many years will the painting be worth 8,000? So now we are being asked to set the desired value at 8,000. So we're going to let P equals 8,000 equals 5,000 times 1.06 to the t. And we are going to actually solve for t to find out how long it will take to get that value. First thing we need to do is divide by 5,000 on both sides. And we have 1.6 equals 1.06 to the t power. The next thing we're going to need to do is bring that t down to the base. So we're going to apply the log of base 1.06, because we know that log base 1.06 and 1.06 is going to cancel out. So we have t is equal to log base 1.06 of 1.6. And so we're going to use the change of base formula, and here's how we're going to apply the change of base formula. So t is going to equal to the log, what's on bottom stays on the bottom, so it's log of 1.6 divided by the log of 1.06. And you can go ahead and use a calculator to find out what that answer is, but I have approximately 8.1 years. So go ahead and practice getting that answer on your calculator. So that is using the change of base formula to figure out. And that's the end of that problem. Next one, you can go ahead and try it before we do this. And let's take a look at the answer. A bank account earns 6% APR compounded annually. That means once a year. The balance B of the account after T months is given by this equation here. So we're going to write down the equation. B equals B naught times 1.06 to the T power. And if the account starts with a balance of $250, how long will it take to triple? So tripling means we're going to have 250 times 3. That's a desired balance of $750. And we're going to let that equal to the left side. And the initial amount is 250. And the rest of the equation stays the same. So we're going to solve for t to figure out how long it will take for the amount to be tripled. So the first thing we're going to do again is divide by 250, and we have 3 is equal to 1.06 to the t power. And we're going to again apply the log base of 1.06 to both sides, and that will cancel out the log, and we have t is equal to the log 1.06 of 3, and we're going to use the change of base formula again. Log of 3 divided by log of 1.06, and we're going to have approximately 18.85 years. And that's how long it is going to take the money to triple. And that is the end of the lesson for today. And so go ahead and get started with your book set, finish your HRW, and then copy notes for 16.2 day 1. And don't forget, Alex. Have a good day.